Okay, we're learning about sigma notation now today. So sigma notation is a fast way of showing the sum of a series or showing the series, right? It doesn't give the sum, you still have to calculate it, but it's a fast way of showing all of the terms, okay? Thank you. So what is really important is that you know how to find the general term of the series, which is the same as the general term of a sequence. So sometimes students get confused on that. But the terms of a geometric or arithmetic sequence are the same terms that would be in the series. With the series, then we can actually find the sum of it, right? That's what a series is. You're adding the terms together. But those actual terms are terms in the sequence and the series. No different formula for that. So for the series given there, determine the general term in simplified form. So take a look. It doesn't state what type it is, so you have to figure it out. Is it arithmetic or geometric? So I always look at second term minus first term, that's 6. And I check third term minus second term, that's 6. Okay? You can keep going. I don't even need to look at whether it's geometric or not, if I'm in this case, because I started with arithmetic. So our common difference is 6, right? So it's arithmetic. And what do we know here? We know our first term is 5. And it says, determine the general term in simplified form. So Tn is the first term plus n minus 1 times the common difference. And simplify it. So expand the brackets and collect like terms. You get 6n minus 1. So, using that general term, we can find any term in the series, okay? Here we've shown how it's calculated, right? So 6 times 1 for the first term minus 1 is 5. 6 times 2 minus 1 is 11. 6 times 2 minus 1 is, 6 times 3 minus 1 is 17. 6 times 4 minus 1 is 23. 5, 6, 7. Okay. So, because we've done this the long way, we know that there are 7 terms. If you're not going to want to do every term like that, right? We can count them up. If it's a finite series given to you like that, just count up. We know that there are 7 terms. If there are a bunch of terms missing and then the last term, maybe you'd have to calculate and use your general term formula. In this case, it's a pretty short series. So, how can we express this in sigma notation? Well, first of all, that's sigma. It's capital S in Greek. So you've probably seen that before. Like oftentimes, I always I lived in Toronto for a long time near U of T, and they had fraternities and sororities. Just gotta check my phone in a sec. And so they'd be called alpha, sigma, gamma. And so they'd have all these math symbols on them, right? Because they called them by Greek symbols. That's capital S, sigma. Lowercase sigma is for standard deviation, when you learn that. Okay, and that's just understood to mean the sum of all the terms when you go from n equals 1 to n equals 7. Okay, so this is the Greek letter sigma, and it stands for the sum. 1 is the lower limit of summation, so it begins with n equals 1. 7 is the upper limit. Okay, so 7. It's kind of a weird word, weird statement there, but. And then 6n, minus 1 is the general term. Okay, so always, when we're finding sigma notation, we need to find the general term, and usually in simplified form. Okay, to the improper sigma notation, find the general term, put it in brackets if it's more than one term in an arithmetic. We usually start it at an index of summation of 1, but not necessarily, okay? But in this case we are. If you are creating the sigma notation yourself from a series, yeah, you're going to start at 1. But sometimes we might give you different starting points, okay? So you just have to be aware of that. And ends at the last term, n equals 7. All right, so here is, we can tell right away it's geometric because the n is in the exponent. Okay, it says write the series in expanded form and evaluate each term. So you would start with n equals 1. I'm just going to show each step and then I'll evaluate. Then 3 times negative 2 to the 2 minus 1. So 1, 2, 3, 4, 5. Okay. So 1 minus 1 is 0. That goes to 1. Anything raised to the exponent 0 is 1. So the first term is 3. 2 minus 1 is 1. So that's just going to be 3 times negative 2, which is negative 6. So I'll just show subtract 6. Plus, remember we talked about that. If your R value is negative, the signs of the terms are going to alternate. So this is going to be negative 2 squared, which is positive 4 times 3 is 12. This should be negative because they're alternating. Negative 2 cubed is negative 8 times 3 is negative 24. And then negative 2 to the 4th is 16 times 3 is 48. Okay. All right, so it's geometric because we keep multiplying by negative 2. Anytime that exponent, the index is in the exponent, that means you're multiplying by something each time, so it's geometric. State the sum. Well, you can just do that in your head, right? So what's that? Negative 3 plus 12 is 9. Plus 24 is 33. Okay, then it says determine the value of this series. So from 1 to 26. That's the same general term. I'm not going to write out the 26 terms. Okay, it says determine, so show your work. So we want to find S26. Based on this, we know the first term is 3. Okay, so we don't have the 26th term, so I'm going to use the formula from yesterday, or the day before yesterday. So T1 times R to the N minus 1 over R minus 1. Refer back to your notes if you need to. So this T1 is 3, R is negative 2, N is 26. Okay. And you can, again, you can put it all into your calculator. If you want to do it in fraction form, you can. So 3 bracket, another bracket, negative 2, close bracket to the 26. Now, if you remember that a negative to an even exponent is positive, you could just put in 2 to the 26. What's up, Justin? Subbed in? Negative 2 minus 1 in the denominator. If you're not using the fraction, then when you're dividing, you have to have brackets around the negative 2 minus 1. Okay. Geometric sums get to be pretty big or pretty negative, right? So you'll notice that we use the letter N for our index, and that's because we started with a series and we came up with that summation form. N equals 1, started at 1. Sometimes we'll use different letters, and often, or particularly, when they're not starting at 1. So I equals 3 here, for example, is the starting place. Okay? That's going to give you your first term. So I is not representing your term number, right? The first term is when I is 3. So it says write the series in expanded form and evaluate each term. So here, first term is going to be when I is 3. That's your first term. Then your second term is when I is 2. Then your third term is when I is 3. Oh, sorry, what did I just do? I is 3 to start, 4 is the next one, 5 is the next one, and I went backwards. 6 is the next one. We have to go to 8. 7, 8. Okay. All right, so now evaluate each term. So 26 minus 15 is 11. 26 minus 20 is 6. 26 minus 25 is 1. 26 minus 30 is negative 4. 26 minus 35 is negative 9. 26 minus 40 is negative 14. Okay. This one, I can tell it's arithmetic to start because it's a linear expression in that summation notation. The variable is not in the exponent. It's not squared. It's just a linear degree 1 expression. Okay? So we know it's arithmetic. Common difference here is negative 5. So state the sum of the series. Well, you can do that in your head, right? So 17, 18, minus 4 is 14, minus 14 is 0, minus 9. Okay, so it says, given a series expressed in sigma notation, write a rule to determine the number of terms in the series using the lower and upper limits of summation. So take a look here. We went from 3 to 8. So you might look at 8 and say, oh, there's 8 terms. Well, count them up. 1, 2, 3, 4, 5, 6 terms. There weren't 8 terms because we did not start at I equals 1. If you think, oh, I'm just going to subtract these two, 8 minus 3, there's 5 terms. Still wrong, there's 6. So when you go 8 minus 3, you're actually missing the first term, okay? So you have to add that first term back in. So 8 minus 3 plus 1 will give you the number of terms. 8 minus 3 is 5, plus 1 is 6. Okay, so that general rule here is you take, so the number of terms equals the upper limit minus the lower limit plus 1. Okay. Hard to know that. Okay, and then also always be careful if it's not starting when n equals 1 and it looks like it's an arithmetic or geometric expression. Your first term, but be careful, put in whatever that lower index is, lower limit is, to get your first term. It's not necessarily the constant term or the coefficient. Okay, so here, state the number of terms. So number of terms will be 23 minus 6 plus 1. So that's 18. Okay, not 23. So determine the first 3 terms of the series. I'm going to just put equals there. So 2 to the 6 plus 2 to the 7 plus 2 to the 8 will give you the first 3 terms of the series. Okay, so evaluate those. Figure out what 2 to the 6 is, 2 to the 7, 2 to the 8. 2 to the 6 is 64. 2 to the 7 would be double that, 128. 2 to the 8 would be double that, 256. Okay, now our sum of this series, it's not going to be S23, it's going to be S18. Okay, so it just says find the sum. Yeah, so S18, we don't know the 18th term, so we'll use that first form of the summation formula. So the first term is 64. Common ratio is 2 to the 18 minus 1 over 2 minus 1. So don't even need a fraction. 2 minus 1 is 1. Right? So I don't have to use the fraction form. I can go 64 bracket 2 to the exponent 18 minus 1 close bracket. Next one looks like it's going to be arithmetic. It's a degree 1 linear expression there. Number of terms will be 92 minus 28 plus 1. So what's that? 84, 64, 65 terms. term will be when k is 28. Second term when k is 29. Third term when k is 30. Okay, and then evaluate each of those. Okay, you can see that it's an arithmetic. Again, confirms it's a linear expression. Now, when we look at it, the common difference is 7. So we want to find the sum of the first 65 terms. Okay, so we don't know what the 65th term is, so we're going to use the first formula, which is n over 2 times 2 times the first term plus 65 minus 1 times d, which is 7. So really, this is a good review of sums of arithmetic and geometric series. Okay. So 65 divided by 2, bracket 2 times 193 plus 64, I'll do that bracket in my head, times 7. So to write a series in sigma notation, you need to figure out what the general term is. And then from there, if you are figuring out and putting this in sigma notation and you're finding the general term, then your first or your lower index will be 1. Then you will have to figure out what your upper index is. What's the last term on that, right? Which term is it? So our Tn will be negative 10 plus n minus 1 times. Here we're adding 4 each time. And so simplify that. Okay, now we can use that for n minus 14 in order to find what n is for the term that has a value of 142. We don't know what n is, right? So for n equals 156, n equals 39. so if you're coming up with a series, you can use n because we're starting at n equals 1. Otherwise, don't use n. If you're starting at anything different than 1, then you'll get confused in terms of term number. But we're starting at 1 and going to 39. And then always, you can check back, right? When you put 1 in, do you get negative 10? Yep. When you put 39 in, so do you get 142? Well, you would get 156 minus 14 is 142. All right, so you go back and check. Okay, so now we have the recursive definition of a series, or of terms of a series. Okay, so then show that in sigma notation. So we know the first term. So first of all, I would write out the first few terms. It looks to be that it's going to be arithmetic because you keep adding. But let's find, so the first term is 29. Okay, so we'll call it a series right now. These are the terms, so plus, and then 29 plus 12, that's 41. Yeah, so this is arithmetic. Okay, we're going to go up to the 15th term. So if we're starting at n equals 1, we're going to go to 15. Okay. Our general term, first term plus n minus 1, what's the common difference? Well, you're adding 12, right? You can tell that. So simplify, we always want the simplified form. And so that's 29 plus 12n minus 12. 12n plus 17. Okay. Okay, let's focus here. So number 7 says determine the value of that. Take a look at it closely. It's going from k equals 1 to infinity. So it's an infinite series. So we learned the formula yesterday. The sum of an infinite is t1 over 1 minus r. Okay, so figure out what t1 is. Usually looking at this, I would say it's 6, but always check because sometimes we simplify if we can. Remember, if that one that we had where it was just 2 to the n, right? You might, well, that one's more obvious. You might have something like this. You might have 6 times 1/3 to the k, where k equals 1. And you might think, oh yeah, I keep multiplying by 1/3. First term 6. That's all good. But be careful, when k equals 1, that's going to be 6 times 1/3, which is 2. So your first term is actually 2. So always check. Okay, you might get fooled a little bit. This is almost like the general term, but not quite. Okay, so don't get tricked. Some of being good at math is good attention to detail. So be careful on that. So when k equals 1, I do get 6 in this case. When k equals 2, then that becomes 1. 6 times a third is 2, and then it keeps on going forever. Okay, so my common ratio is 1/3. Okay. And then your practice. So here's an example. Well, actually, no, that starts at 0. Just wanted to see if we have an example where it starts at k equals 1, but has, yeah, so here, this in the practice starts at k equals 1, but this is not k minus 1. So your first term here is actually going to be -12, okay, not 4. So be careful on that. This one here, your first term, you might think, oh, maybe it's 1, but it's not. It's when, well, actually it is. But not by, that would be fluke, I guess, if you thought that. When you put 3 in, 3 minus 3 is 0, 5 to the 0 is 1. Okay, so just always find the first couple of terms to make sure you're good. That's it.